Good morning, student. I am SONU SINGHAL, and we will discuss shear stress, principal stress, and principal strain in this lecture. Okay, guys. Now, first of all, we start. What is shear stress? Shear stress is acting on the side of the body. We can see this diagram. The shear stress is act in the side of the body. When we apply the force in the left side of the body, then body is acting on this type, right? Actually, shear stress is directly proportional to the shear strain for from the Hooke's law, and it is denoted by tau, where tau is the shear stress and its formula is internal resisting force upon surface area, right? That is equal to F upon A. F is the force and A is the surface area. The unit of the shear stress is denoted as Newton per meter square, kilonewton per meter square, kilonewton per mm square, Pascal, megapascal or gigapascal, right? It is also tensor quantities. We can explain shear stress from this cubic box where x, y, z directions of this box and shear stress is acting at this type, right? We can calculate shear strain from this diagram, right? Shear strain is change in the length upon original length, that is equal to tan phi, where phi is the angle. When phi is very small, that we can say that tan phi equal to phi. It is denoted in radian, right? From the figure, we have sin phi equal to CD upon BC, that is del L upon BC, and cos phi equal to we have AB upon BC, and we know that tan phi equal to sin phi upon cos phi, right? Solving this, we have the value of tan phi, that is del L upon. Now shear strain, it is change in the length to the original length, or it is change in the right angle, so that is shear strain. Okay, and modulus of rigidity, it is denoted by G or C. Shear stress is directly proportional to the shear strain by the Hooke's law. That is, we can express this by this relation. Tau is directly proportional to phi, where tau is the shear stress and phi is the shear strain. Tau equal to G, where G is the proportionality constant or modulus of rigidity, right? The value of G equal to tau upon phi, that is unit of G is Newton per meter square, kilonewton per meter square, Pascal, gigapascal or megapascal, right? It is property of the material. Now we explain the principle of shear stress or complementary of the shear stress, right? We draw this diagram, and the shear stress is denoted by this around of the figure, and explain the shear stress from this figure, right? So we can find out force on the plane ABCD. Force is stress into area, where tau is the shear stress and area is del x into del z. Same to same, we find out the force on plane EFGS. The shear stress tau and area is del x into del z. So we can see that couple of the plane, that is tau into del x into del y into del z, right?